Hey everybody, my name is Denise Augusto. I'm a professor at the College of Computing and Informatics at Drexel University. Although these days I'm actually a professor in my bedroom or in my dining room. I'm happy to see everybody here for the next in our series of webinars that are related to our Masters of Science in Information. I think I got that backwards. Masters of Information in Science, the MSI program here at Drexel. Today's guest speaker is Xia Lin, who is professor here in the College of Computing and Informatics, and he's also the head of our Information Science department. He's going to talk about information seeking and knowledge graph. So take it away, Xia.
Hi, thank you, Denise. Welcome, everyone. So this is Dressel's MS in Information's webinar series. Each month, one of our faculty will talk about a select topic the faculty is interested in or doing research on, and they are related to this new degree program. We are very excited about this new degree program. Officially, the name is Master of Science in Information, with 3 majors: Library and Information Science, Digital Content Management, and Human-Computer Interaction/User Experience. So we have been doing all these for many years. Now this is like first time we are officially giving a major, separate as a major. LIS, we have, like Dressel's LIS degree has been, how many? About 100 years, and digital content management, we're teaching all these in there. So that's why our faculty are exciting. They can talk about how their research, how their knowledge relevant to the courses we are teaching. Let's use mine as example. For example, let me introduce myself in a way academically. I got my LIS degree from Emory University long time ago now. But that is a very different environment from that. And that is the first time we start to have a computers there. And the first computer we use there is without hard disk. We see floppy drive. It's already very exciting for that. And then I got my PhD from University of Maryland, College Park, so it's not too far from Philadelphia. And after I got my PhD, I went to Kentucky to have my first teaching job there as an assistant professor. And since then, I've been a Drexel from assistant professor, associate, full professor, just keep going for more than 23 years of teaching research service. Well, right now we call it College of Computer and Informatics. Actually, the college, name of the college had changed 3 times in these 23 years. It's College of Information Science and Technology, and well, anyway, and then iSchool, and then the College of Computer Informatics. So even though it's keep changing, the fundamentals are still the same. Here is, I just do a copy of my website. It's some of the courses I'm teaching in the past 20 years. For example, I teach a digital library for many, many years. Digital library technology, information architecture, and then some topics in information science. So you see, this is kind of libraries and human-computer interaction, database, information retrieval, and there are also some others. That's what I mean. In a way, we are teaching all these courses for many years. Some are LIS, some are digital content management and HCI. This is the first time we are officially making a 3 majors, so students can choose their specific major in the same time taking courses across these domains. My research area, as I've talked about, the first area is information visualization. I'm talking about knowledge graph later. My dissertation is on self-organizing semantic map for information retrieval, actually. So it's about how we're using neural network algorithm to automatically organize a map for the information underneath. So after I do this, I found that map could be potentially useful for visual interface for information exploration and discovery. That's like connected visualization to information retrieval and knowledge organization. For doing the mapping, so essentially now we are doing what I call knowledge structure mapping. For example, we do a lot of metadata mapping, thesaurus mapping, and citation mapping. All these start to using the mapping technique to reveal the structure that's hidden inside the knowledge, inside the literature, for example. That's eventually now is every time I do a presentation, a lot of people start to say, oh, is that like a GPS for the knowledge space? I say, yes, that's the idea. That eventually we want to have some GPS for the knowledge space. That's like how research goes. And then in order to do that, you of course, you need to connect to the human side, how people are using it, or what are the information seeking in the digital environment. How, when we do all these, the purpose is to help the human looking for informations. So that's my research. Using today's example, for example, this is the prototype I will talk a little bit more about Visual Concept Explorer later on. So that's the idea. We're searching for coronavirus. Now, everyone think about how the coronavirus connect to disease outbreak. Outbreak. So in this case, I just searched for coronavirus, exploring coronavirus infection, and then doing a mapping. This mapping is built on top of the PubMed, like going through the whole PubMed. What kind of connection could we explore from coronavirus to the disease outbreak? So there you will see disease outbreak is connected to SARS. That's the previous major outbreak that some related coronavirus. And then this is a kind of disease. So this is an example that if we can build it well, that will help the scientists or even every general users to see what kind of connection that we need to be able to identify or help people understand the kind of relationship that's hidden in millions of literature in PubMed database. So that's the idea that I'm going to talk about today. Information seeking. That's information seeking a knowledge graph. That's what I'm going to talk about. Let me explain a little bit first about information seeking or human information seeking. Very briefly, we can talk about is just someone making efforts to obtain information. Let's go human information seeking. In order for that, first, the person need to have a question, right? A question in the user's mind. Then the user need to have a motivation. I have a question. I need to find information that can help me answer the question. Or if I have a problem, I want to solve the problem. Then I need information. I even not sure, but I need to find that, whatever the information that help me solve the problem. That's the beginning of information seeking. You need to have a question, you have the motivation. Now you need to have a process or activity to implement the process. Either you should identify a source or system and then start to formulate a query that can be searchable for the system. Like if the question just in your mind may not searchable until you formulate into a query to make a search. And finally, you need to interact with the search query results. During the interaction, you modify your query or you modify your idea of what kind of information that's the best for you to help you solve a problem or answer your question. That's throughout the process, you're making judgments or you're making associations from the question to the information you found, or to become a new question you ask for that. So that's the kind of process it's called information seeking. Then what's the knowledge graph? In general, we can consider knowledge graph is a graphical representation of information and their relationships. That's what we saw. A lot only just each individual item. We're really interested to see their relationship, how these informations are related to each other, or semantically. Sometimes we call it semantically. So that can help us understand the relationship, just like the previous example, how the disease outbreak associated with coronavirus. That's of course, it's a very huge questions. There's kind of connections that we want to looking for that. Can we make this kind of associate relationship visible? That's idea of a knowledge graph. In order to do that, we need some base, the knowledge base behind it. So the knowledge graph is also emphasized, it is a knowledge base. You need a huge knowledge base and even some kind of logic inference behind it to come up with those suggestions, relationships. Just like earlier map, actually is based on the whole PubMed literature. Then there's a lot of entity relationship building up in the database, and there are some machine learning algorithms running before we can present a map of the information, a map association. So this is a big part of knowledge graph is the knowledge base that will enable machine learning and AI and sometimes machine understanding. How can we derive the most relevant information? For example, everything is connected. Now, which connection is most relevant? That's require a lot of machine learning behind the scene in order to generate a map. So the knowledge graph is also a system tool that we can use for knowledge creation and curation. I think this is become more and more relevant to, say, library and information science, how we curate the knowledge in a way that will help us understand the literature that in the database or use of the knowledge to different domains in this. Again, every time I talk about this, is a question become a GPS for the knowledge space. So let's go back to think about physical space. Why now we are all so much depend on GPS? We use GPS for navigation. If we know an address, we just type it in, then we can find a path from A to B very easily, the map, or explore the neighborhood and all this. We can do so many things about using the GPS. So my question to you, or to you, think about how was GPS created? What information is needed to create GPS? Just take a minute to think about. So sometimes we automatically just say, oh, I just using GPS, I'm driving, now I can go from A to B, without even need to think of what are the information behind. Actually, the question may go back long way. So first is that's why I'm always interested in the history of maps. When was the map was created? That part perhaps is before we answer GPS, we need to have a map first. Since I'm teaching digital library, I often introduce people to all many different kind of digital library. Like I always like to introduce this World Digital Library. That's a library of Congress, and many other countries joined together to develop this World Digital Library. A lot of historic stuff, like between 8000 BC and 2000. I don't know how many years in between these. So there's a lot of information there. If you look for history of maps in this digital library, that's what I can find sort of a very earlier world map that was created for this. Where if you look at this example, or if you go back to this World Digital Library, you see that earlier map is not necessarily accurate, but it starts to serve for the purpose. So this is they are possibly this is the map that was used by Columbus when he traveled across the oceans. That's the kind of leads we need to navigate through these kind of things. Or if we look a little bit into more detail of this, you see this is a map, an earlier map. What do we see here? There's only some islands. There are a lot of oceans, the boats, and maybe these represents dangers. What are some of the dangers there? So I think that's the idea of the earlier map. Is we need a tool for navigation. That's kind of the first step. And then we need to go from A to B, and they may have some danger in between. If we can avoid, if we can identify later that, then the future people can go through it a little bit easier. What I'm thinking now, we are just starting at these levels. Could we develop some kind of knowledge map that start to help people go from A to B, or identify potential challenges, how you go to certain place to get what you need, these kind of ideas. So that's what, so to answer that GPS question, we really have 1,000 years of history that slowly get to what we have today. Now, similarly, we might need some time to be able to create a GPS for the knowledge space. Currently, there's a lot of research. We are not really getting to GPS for knowledge space yet, but there's a lot of research on this knowledge map, or for the distance. In order to create a map, that's some kind of measurement that need to be created or be making useful. Really, the map is based on some kind of measurement, distance, or directions, east, west. If we be able to identify that in was the knowledge space, or some kind of landmass. In order to generate a map, it's very important that start to create certain landmass in the space. So that people can identify those landmarks and going through for that. So there's a lot of research, knowledge graph in the sense that will help people do research in all these areas. One of the earlier knowledge graph is Google's. Google actually publicly announced on May 16, 2012. Oh, it's close to today. Today's May 13. It introduced the knowledge graph, things, not strings. That's to kind of answer the question. Most of the time, searching is based on strings. You type a query, the search engine convert the string of your query to do the search. But what we really need to know is people, place, and things, and understand the relationship among topics and things. So that's the idea for the knowledge graph. Once Google huge connections and then a huge computational power could help them build up this huge knowledge base that can be used to help precision of the Google search engine, like the enhanced search result, so that understand the search query better. We get used to, we just type a few letters, see queries start to pop out, we can select one. A lot of these is based on the knowledge base behind it. So that's the initial idea for that. But so that's the example that Google used to say this is the kind of knowledge graph they envision in this 2012. They say they can use 2 or 3 years. Their future interface search engine could become like this. But that is never, after 2 years, 3 years, 4 years, many years, they recognize that it's not that easy to get to this level. So they essentially, most is built into what is called knowledge vaults. Continue building up their knowledge base and making this knowledge can do a lot of machine learning, supervised, unsupervised, all different kind of learning, and building up something like this, a more simple box, like information box, instead of in the middle one. So we have this is search result. So right now, Google is kind of getting this search result plus the box. This getting the most relevant information here. This is still at experimental stage. Even after now, how many years? 8 years, 10 years. This is still not easy to get to here. So this is still the research, but this box is already found it's very useful. That box information is coming from the knowledge graph. All the information from there. Oh, they call it knowledge bar. Another example is IBM. We all know that Watson have been compete in the double jeopardy that show the demonstration of machine intelligence. That is, in order to do that, is IBM also using the natural language processing plus machine learning to build a huge knowledge base that can doing all kind of questions, answering, hypothesis generation and testing before they can answer the questions. That's underlying. It can also, it's called knowledge corpus or knowledge graph. Essentially, it is also a knowledge graph. So their emphasis is from text corpus to knowledge base. That's the IBM focus on many years to working on be able to decompose expression into entity and then combine them so that to help for the semantic annotation and deep parsing. So that's a large base. Or in general, this is also large graph we talk about. Going back to today, large graph 2020, because today's environment, we just have a conference on this large graph conference. It's fully online. Last week, it's this May 4 to 7. So I participate or seeing a lot of presentation there. We see now large graph have come to a next level. It start to from large space to applications. I see it's large, like a large graph for recommendation system, building a large graph for visual analytics, enterprise large graph, and there's some like a large graph for personal health data, and a lot of application. That's what I see is exciting is we spend a lot of time, or scientists spend a lot of time building up this large graph. And in the end, you will still need to make into a practical application so we can see how large graph can be applied or help people find it. Let's go back to my research. I'm thinking my motivation for research is always using this kind of mapping large graph to enhance human seeking. So in my early research for map display, I try to use the map. One advantage of map or graph is they can convey very large amount of information in the limited screen display. In the same time, to showing a semantic relationship, allowing interactive browsing, navigation. So that's the idea for that. That's map display building on top of large graph or large base. So we can use the computer to assist whatever the machine learning lab or neural network and algorithm is behind the scenes. They will help the user interact or seeing the relationship, interacting with the information through the visualization methods. So I also need to do a lot of work to build up the knowledge store, not like as big as Google's large graph. I focus on building the large stores. So many different words, large stores or large base, ontology. I'm doing research on top of ontologies or classification systems, thesaurus. A lot of these are LIS related. And then doing learning, putting a learning algorithm on top of that. Finally, studying how people interact with this. I can see this is sort of a human-computer collaboration. Machine learning suggests the link, and then it is still the expert look at this, or the machine learning is based on experts' knowledge, like ontology is sometimes based on expert knowledge, building up the connections for that. I call this human-computer collaborations. We need humans' knowledge and then put it in knowledge space and using machine learning to highlight the connections in the end. People interact with these kind of things. So that's the research. I think now I would just want to show some of the prototypes I have been working on for that. So this is just in order to do that, I would do a lot of behind the scenes work on large base construction. For example, in this particular one, I see using mesh term, medical terminology used for PubMed indexing. So mesh vocabulary. This is like sort of this is PubMed. This is a mesh indexing term. How these already we already have human indexer that index these. In the same time, we can do more machine learning to do extractions of indexing term. Just say a lot of activity that before we could do the visual display for that. So this is just some of the paper I published. This is a very earlier map. You can see this is kind of earlier. Actually, part of my dissertation is how we organize this information semantically. Let's say it's a whole collection. Organize highlight the content of the collection. I call it graphic table of contents. This is a kind of like idea of table of contents, except it's graphic, it's classification, it's a lot of connections. If two terms are close together, that means there's a more information talk about these two concepts. So this is earlier result. I'm also doing citation-based mapping. This is like based on how many times authors are co-cite together. So this is if you are in library information science domain, you will recognize this Machnini, Christine Borgman. So they are doing some research together. Marcia Bates, Nick Berkin, and all those things, and how they relate to each other. So that's based on co-citation. I show these to these kind of authors, they all immediately recognize, oh yeah, I know this person, I know we do a lot of research. Sometimes not they do, it's a lot of people citing them together to make the link. So that's in a way is how research in that domain, seeing how these authors are related to each other. That's the citation-based mapping. Now VCE, that's as I said earlier, I can do all different kind of mapping. Each time you type one word semantic, you would look into the UMLS terminology, seeing the relationship. So these relationships are based on co-occurrence count of the whole PubMed literature database. So there's a lot of like semantic related to attention, visual perceptions, and all this. I also do more global mapping. So this is a Dewey Decimal Classification number for digital library. This is a kind of the whole digital library they're mapped together based on the Dewey Decimal number. In general, this is like this is 600 about science. There's 900 there, and their relationship. There's a lot of detail. So, in general, this is only can be considered as a global view. If you need to look more into it, so you need to have more interactive view. Zooming or doing a research, start to see more detail, like how many documents are in that particular category. Each of these number is a Dewey Decimal number, starting to see that, how they relate to each other. That kind of interactive view can continue to go on as you zoom in more and more to find a more specific link. Like if you are curious about a specific link, then you need to zoom in more to see the relationship. Finally, let's using a very specific example to talk about information seeking by knowledge graph. Let's say search for a term. How do we search? When you type the term code, what does that mean? What do you searching for? Right? Or what kind of information you're looking? That could be many different ways of searching. because syntactically, that's generally mean you just search by string, code, or semantically or conceptually. This is another example I use built on top of Wikipedia. That's just sort of as a demonstration. If you want to search code, syntactically means code. Code word show up, like code, a code case. Here is code play. So that's really mean you search the word code by the string of code. So that's the syntax. Or you can search the word by its meaning, the semantic. Code means what? Mean the temperature code. If you search by temperature, the code, then what you see is snow, winter, ice, or the reverse, like cold and heat. I always like to show these are examples. Typically, search engine search is by list. Where you type a string, you search code, you will find any term that have the string COLD. Find it. Let's kind of, I just pick 5 most related terms. But these already need a lot of work. How, when you type the code, how you relate it to this for that. Or conceptually, actually, the system should ask the question, what do you mean by code? Do you mean by, actually, it's not just cold temperature like we saw earlier. It may also mean common cold or some kind of cold disease. Which one do you mean? That's the search engine ideally should be able to detect this kind of multiple meaning of that query. And then to start, say, if it's a common code, then you want to do you want to do some a mapping. So now it's like if it's common code, that's more specifically is these are the literature talk about common code or common code, the relationship of common code to Lyme virus or some human influenza. And these and a lot of that. So let's give them, actually all these are more can be interactive. You can interact with these to explore relationship. If it's a cold temperature, you see the map would be very different. Like this map is about common cold. So all these terms are related to medicines, cold treatments, and therapies. And then if you go to the cold temperature, let's start to about body temperatures, body temperature. This is a medical literature. Cold temperature meaning some kind of body literature, how human body react to this kind of different temperature. And all these muscles, skins, pain, and all these, that's kind of relationships to see. We start to see this kind of the difference. Again, this is the first view. The user may interact with this for them. So let's if we have time for demonstration. Should I stop here to see if anyone have any questions so far?
Sure. Thanks, Sean. That was really interesting. You did get 2 questions in through the chat. Would you like to take those?
Okay, yes.
Sure. Let's see. The first one, could you talk about which knowledge bases might need to be built now to leverage KGs in future? For example, health-related, supply chain, economic relationships?
Yeah, there are many different knowledge graphs that has started build, like Google one, as I mentioned, they are very genetic. That's I will cover all if the specific medical domain. That's I like to using those information from NIH and NLM, National Life and Medicine. They have more specific information from our medical literature that can be built up for that. Actually, that's I mentioned about UMLS, the Unified Medical Vocabulary System, language system. There have been a lot of work have been done on that. I like the kind of knowledge base that's built on top of this kind of vocabularies. That means that's already a lot of human knowledge built into it. It's not just the text, it's already have a, so there's like a metadata, vocabulary, even control vocabulary. It's already relationship that sometimes very hard for a machine to detect. If the human already built some relationship there, we can use this kind of relationship to help building, set up the knowledge graphs for that.
Okay, very interesting. Then the next question was, could you speak about embeddings and why they might be important moving forward?
About embedding?
Embeddings?
Embedding the, yeah, that's, I mean, what do you mean by embedding?
I don't know.
Interaction with interactive or zoom in, zoom out. It's sometimes one is about interaction, is how you zoom in more and more. Like in the example of in the example earlier, say this is a global view. Nobody can really see the detail on the global view. So later in visualization, it's always you have a global view first. There you should provide zooming and interaction until people can get into more detail, seeing the relationship. That's also the research I do, and finally I can see this is generally you could display, like I display 25 terms here. I could display 100, then the relationship are too complicated. It really lead to limit the amount of information. But in the same line, the reason we use machine learning is to highlight only the most relevant links instead of every term. Actually, all these terms are related to each other. The machine learning will help us is highlight the most relevant term so we can start to see the structure of that.
Okay, that makes sense. That question came from Gary. If you have a follow-up, please feel free to ask it.
Yeah, any other question? Okay.
All right. Well, if there are no other questions, then thank you, everybody, so much.
I see that. Well, we still have some time if anybody wants to stay here.
Oh, sure. For another.
Well, I try to. Okay. Let me just get to my final slide, and then we can come back. If we have time, I can do a quick demo for that. So. We talk about knowledge graph, and particularly what I'm interested in knowledge graph for information seeking. So knowledge graph generally requires significant work to convert data to knowledge base. Again, the thing about GPS is how much data behind the GPS. We are not there yet, but there's still lots of work needs to be done to convert the data to the knowledge base. So that is a global goal for the interdisciplinary research. There's a research in many different directions, like a content analysis, semantic analysis. In the same time, we also need to understand from human side, human information seeking behaviors, like a lot of research on that. and how we create map, like history of map. That's why I mentioned history of map. Now we are just in the early stage of creating large map, how we create it, how we link these large map together, or curate them, and interaction. So all that's much more data science, machine learning, AI, and all those could be connected to the knowledge graph. Well, go back to our degree. I would generally say that's why I say our faculty, including me, myself, my research, within all our research is built on top of the knowledge in library information science, digital content management, human-computer interaction, and all these. We'll talk about this in our courses, and hopefully future students will learn more, and then they will come to contribute to our goal to build more knowledge graph that will become future of GPS for the knowledge space. Okay, thank you all. Now, if you like, let me see if I can turn on my system to do some quick demo of that. I need to stop sharing of these. Where's my power? Okay. Okay. So this, let's see, like if I search the code, that's I need to wake up my system. So this is like example I just talked about. If I search code, it will suggest a multiple mapping. Then which one you will pick up for that? There you will check. We saw this. If we select that code, common code, this is the kind of common code here. That's why I say that 25. I can pick. Actually, I try to say that you can have 50 or you can have more of that. Now the relationships start getting complicated. Yeah, from common cold to antibacterial agents and family practice. And all these, you can make adjustment of these, of that. So the color, so this is outline, that's a category of these things. If there's substance, if there's event, or that. Say now you say, well, really, if you're interested in this, you can double click on that. Now you do another mapping. You do another mapping of that. So there's a lot of relationship and learning behind it. So actually each time you click on these, there's a search to the knowledge base, and you start to see like a new relationship from that. Just as I say, 25, typically I try to experiment that 75 is already too many. The most people prefer just 25 term on the screen. That's sort of like you can see. You can kind of see this is like a. I'll say you can do the search to you can do the search to the PubMed. Let me see. You can add a term here, or you could change the search term and all this. So I say this is kind of just a exploration or graphic display of the huge, large graph behind. Okay, that's a quick 3-minute demonstration of that. Anyone have more questions?
Ask a quick question?
Sure.
You talked about, the automatic and the machine learning analysis of the data. I wonder if you mean something like there's lots of data sets out there from experimental results, and then, is they're combing through the data and trying to find relationships? Is that like an automated thing? Is that an agent thing, or?
Yes, I think it's also like also a lot of coding need to be done. For example, I also do some mapping for pharmaceutical company. They have tons of data, but they all have coding. Then they have some kind of structure there. They want to say that I have 3 million or many million of data set. They already have some relationship there. Then how we identify which one is most relevant, which one is more, for example, they have some kind of drug like a week. There are always 1,000 ways to do clinical testing. For that, which one should I do first? There is a machine learning or graphically, you can help them to see which direction they should go. That's why earlier I mentioned I like to see some structure before inside the knowledge graph. That's either all literature already indexed by control vocabulary. That usually will show a better knowledge graph rather than complete free text, for example. From free text, I can also identify the keywords. Then there's much more noise. That requires even more learning process to identify what are the noise and what are the more meaningful semantic relationships for that. Yeah, a lot of database, you can apply this kind of things to a lot of medical domain database and also financial database. They have certain structure there. And it's just a large graph or visual display will help them focus more or bring out the insight from the database. Okay. Okay, any other questions? Yeah, no. Okay, thank you. Thank you all. Thank you very much for spending some time with us. Denise? Mm-hmm.
Thank you, everybody. We really appreciate it. We hope you see you on future webinars in this series. And we hope you're all doing well wherever you are and however you're weathering the pandemic.